Hello, pre-algebra. Mr. Lawrence here with your flipped lesson, more on perms and combos, permutations and combinations, that is. I do want to remind you that in a permutation, the order matters, right? Ooh, am I working? Doesn't look like I am. There we go. In a permutation, the order matters. So, now I've told many of you what I do is I write down an outcome. I change the order and see if I get the same thing. If I do get the same exact thing, it's a combination. If I don't, it's a permutation. But a lot of you won't listen to me and you won't write down an outcome. And that's why you'll get these wrong. So let's take a look at these and see if we can identify them. I have question number 1 is, in how many different ways can you rearrange the letters in the word warned? Now, it is important to note we are only changing the position of the letters. We're not concerned with getting an actual word. We might get an actual word, but it's okay if we don't. So I have warned. That is one outcome. Warned. Whoa, what is that? That does not look like a W. Let me write it. I have warned. There we go. For some reason I changed to black there. Sorry about that. All right, and now I'm going to just change 2 of the letters and see if I get the same thing. I'm going to change the R's position with the W's position. And I have wronged, which I doubt is really even a word. But if I had said, I warned you, I warned you, I warned you that the tornado was coming, you would look at me like, what language are you speaking, Mr. Lawrence? Of course, many of you look at me like that anyway. But you know that warned and warned are not the same word. So does the order matter? Yes, the order matters. Yes, the order matters. That makes this a permutation. Now, to solve the perm, remember, I ask myself, how many things am I choosing? Well, I'm choosing 6 letters. 1, 2, 3, 4, 5, 6. And how many choices do I have for my first letter? Well, there's 6 letters. I have 6 choices. 5, 4, 3, 2, 1. And I multiply them all together. This is a very special type of perm called a factorial. It's actually, this situation of perm ends up being a factorial. I should say that. That's more correct. You can find a calc on your PRB button on your calculator. Sorry, the PRB button. You can find an exclamation mark. You could type in 6 exclamation mark. It's pronounced factorial, and it will do the math for you. Now, I know from experience that this will end up being 720. So there are 720 different ways to rearrange the letters in the word warned. Okay, there's 2 ways right there. 1, 2. But if I tried to list them all out, I would have to get 720. And that would be kind of difficult to do because I might make a mistake along the way. All right, let's see here. A local astronomy club wants to have a party on June 5th, the last time anyone currently alive will see the planet Venus in transit with the sun. It actually won't happen again for something like 187 years after that. I knew it, I'd said it was like 30-something years. I knew it was a long time. I had no idea it was going to be that long. Yeah, I guess it happens twice in about an 8-year period, and then does not happen again for like 187 years. And then it'll happen twice in an 8-year period and then not happen again. It'll follow that cycle. Pretty amazing stuff. All right, so they want to have a party. The club has 50 members, and they think they should have 10% of their members on the planning committee for the party. How many members is that? What is 10% of 50? I hope you're not doing a percent proportion. I hope you just know that to divide by 10 would get you 10%, and that would be 5. So I need 5 members on this committee. Let's pretend that the members are, let's see, who do I want? Bob on the committee. and we want cat on the committee. It doesn't matter what their names are. I'm just putting down real easy words. And I want dog on the committee, and I want Sam on the committee, and I want Tim on the committee. All right, so there is my committee of 5 people. But somebody miswrites it and says, you know what? The committee consists of cat, dog, Bob, not Bob, Tim, and Sam. Did they make a mistake? Did they get it wrong? No, they've got the same exact committee. They just listed them in a different order. All right, that's okay. That's okay. They have the same exact committee. This, ladies and gentlemen, is a combination, a combo, because we changed the order and we got the same exact thing. Now, I like to do combos very much like my perms. I ask myself, how many things am I choosing? Well, I'm picking 5 committee members. 1, 2, 3, 4, 5. 5 spaces for my committee. And then, if I made 5 spaces upstairs, I need 5 spaces downstairs. Remember that we need division in a combo because we don't want to count these 2 lists as separate things. They are the same exact committee. We don't want to count it twice. The division gets rid of me accidentally counting things more than once. All right, right here. How many members do I have to choose from this committee? Well, before I've picked anybody, there are 50 members that could be on the committee. Once I've picked somebody, there's only 49, and then 48 are left, and then 47, and then 46. Now remember, here's the hard part. I put a 1 there, and I count up until I run out of spaces. All right, so I'm going to do some simplifying. I see that 5 goes into 5 once and into 50 10 times. I know that 4 goes into 48 12 times. Goes into 4 once. 3 goes into 12 4 times. 2 goes into 46 23 times. By the way, these are all turning to ones. Once my denominator is all ones, I'm ready to multiply. I'm going to have 10 times 49 times 4 times 47 times 23. Oops, you can't see that, can you? There we go, I snuck it in. So 49, 47, 23, 4 and 10. So I've got 49 times 4 times 47 times 23. I don't want to forget the 10 that's at the beginning. And look at that. That is how many times, or how many different committees I can form. 2, 1, 1, 8, 7, 6, 0. Put my commas in, and I get 2,118,760 different committees of 5 people that I could choose from a 50-member committee. That is just mind-boggling to me. That blows me away. All right, let's check out this one. In the middle school spelling bee competition, there are 35 contestants. The top 4 candidates will advance to the next round. Hey, let's keep this real simple. Let's pretend the guys that go to the next round are named A, B, C, and D. Oh, let's change the order. Let's say that B, A, D, and C qualified. Is that the same thing? Like, who gets to go to the next round? A, B, C, D. In the red situation, who gets to go to the next round? A, B, C, and D. So you see the order on this one does not matter. That makes this a combination. Yes. And I'll have to scroll down a little bit. Ding, ding, ding. There it is, a combination. Whoa. It's celebrating for you because you picked the right one. All right. Since it's a combo, I know I'm going to have the division. I ask myself, how many things am I picking? 35? No, I'm not picking 35. I'm picking the top 4. So I need 4 spaces. 1, 2, 3, 4. I draw my fraction bar. 4 spaces upstairs means 4 spaces downstairs. All right. How many people do I have to pick from for my you know, from all my contestants? Well, 35. At the start of the competition, there are 35 people that have a chance. Once one's in first, then there's, oops, silly mistake there. Once somebody's in first, then there's only 34 to finish in second, 33, and then 32. On the downstairs, remember this is the hard part. I fill in a 1, and then I go 2, 3, 4. I don't know if I mentioned, I am multiplying all these, and I'm sure you can tell me it's because of the fundamental counting principle. All right, I'll begin to simplify. Let me see here. Well, I know that 2 goes into 32 16 times. I know that 4 goes into 16 4 times. Remember, those are turning into 1s. I sometimes get lazy with that. 3 goes into 3 once and goes into 33 11 times. My denominator is turned to all 1s. My numerator is 35 times 34 times 11 times 4. So where did my calculator go? So I'm going to clear this out. 35 times 34 times 11 times 4. And there we go. My answer is 52,360 different ways that that 35 contestants could finish in the top 4 spots. That's pretty amazing when you think about it. All right, one more sample problem and the lesson will be over. All right, in the final competition for the spelling bee, there are 200 total contestants from all over the country. The top 5 finishers each earn prize money. First place earns $500, second place $400, third place $300, and so on. All right, so how many different ways can 200 contestants finish in the top 5 places? Well, first, let me decide if it's a perm or a combo. Let me go A, B, C, D, E in that order. Then let me change that order to E, D, C, B, A. Does it matter? You bet your boots it matters. Look, first place finisher gets $500, right? So who's getting the $500? In this scenario, it's A. But in this scenario, A is only getting $100. How do I know that? Because I just counted down from 500. Here, E is getting the $500. Do you think if E won the spelling bee and they accidentally gave the money to A, he would be upset? You better believe he would. All right, so this does matter. So I know that this is a permutation. I like to call it a perm. All right. How many things am I choosing? I'm choosing the top 5 finishers. So 1, 2, 3, 4, 5. All right. At the start of the competition, how many of these top 5 people have a chance to finish in first? Well, 200. Once one's in first, there's 199 left, then down to 198, 197, and 196. This is going to be a large problem. So let me see here, 200 times 199 times 198 times 197 times 196. Oh my goodness, look at the size of that number. I don't even know if I'm going to try to read that until I have it rewritten with commas in place. Because reading that off the screen I find difficult to do. So I'll do my comma dance. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. All right. Let's see here. This would be the millions place, right? So this is billions. 304,278,000,4,800 different ways that those top 5 finishers can, excuse me, that's 200 contestants can finish in the top 5 spots. Pretty amazing stuff. All right, Mr. Lawrence signing off. Have a good night, everybody.